Hello student, welcome back to lecture series on numerical solution of ordinary differential equation. Okay, so already I have uploaded plenty of the video based on the solution of ordinary differential equation using numerical method. Okay, within that I explained Euler method, Euler method and a modified Euler method with some of the examples. Okay, so if you are interested to see this video guys, go and check in here in I buttons, or you can check in my description box too. Okay, so down here. So in my today's video guys, I'm gonna explain to you all complete Kutta method for the second order. Okay, so if it possible we go for the fourth order too, and in our subsequent lecture we go for some of the examples. Okay, so without further ado guys, let's get into our today's lecture. First of all, we're going to understand what is the Kutta method. It is a very much important method guys. Definitely you will get the question based on the Kutta method in your exam. Okay, and it is one of the easy method if you have understood like Euler modified method, Euler's method. So Kutta method, it is completely based on this method. Okay, this Kutta method is an extended part. Okay, it is an extended part for these methods. Okay, the Kutta method do not require calculation of higher order derivatives like a Taylor series, and it is designed to give greater accuracy with advantages of requiring only the function values at some selected point on the given interval. Okay, so this method is widely used everywhere. Okay, as compared with the Taylor and Euler methods. Okay, so Taylor method, Euler method, these are the quite time taking, okay, and less accurate than Kutta method. Okay, yes, so we are going to consider here first of all for Kutta method, Euler modified method, some results from Euler modified methods. Okay, and that we are going to extend it here in a Kutta method. Okay, so let's get into our today's Kutta method. It is one of the easy guys. See very carefully this one. These are the very much important method for your exam. Okay, not for exam, it is for your daily calculation tools. Okay, yes, let's get dive. Okay, so we all know that the Euler's modified formula. Okay, what is the Euler's modified formula? Euler's modified formula. Okay, what is the Euler's modified formula? So we know that the Euler's modified formula we used here as a y1, which is equal to, okay, I explained it into my last lecture. Okay, how that formula coming. Okay, y1 is equal to y0 plus h by 2. Okay, f of x0 y0, f of x0 comma y0 plus f of x1 comma y1. Okay, this one is our Euler's modified formula. Okay, x0 y0 plus x1 y1. Okay, and we know that the x0 x1 x2, these values how it is coming. Okay, x0, if you want the x1 we write x0 plus h, if you want x2 then we write x1 plus h. Okay, and if you want x3 we write x2 plus h, and so on. Okay, these are the value that we needed here for x0, x1, x2, x3. Okay, yes, so this value we are going to consider here. Okay, x1 we consider. Now see that for our first iteration we consider from the x1 is equal to x0 plus h, and we know that the beginning iteration for our Euler modified method, that we used it into the Euler's method too. Okay, so x1 which is equal to x0 plus h. Okay, this one is our first iteration. Okay, yes, and y1 we know that y1 we consider as a y0 plus h, y0 plus h, f of x0 y0. Okay, y1 we consider y0 as a h plus f of x1 or y0. Okay, f of x0 y0. This one is our first for our first iteration. Okay, subsequent you have to replace the values in our Euler modified method. Okay, so let me explain how the second and third values are coming. Now how I am going to create the value for our first iteration of Euler modified method. Okay, which actually we call it as the second order Kutta methods. Okay, so we are going to find out the different iteration over here. Okay, so now see that using Euler's modified method. Okay, this one is the Euler's modified method. Using this formula, So I'm going to define our first Runge methods formula, okay? Yes, for our second order Runge method, okay? So now see that y1 we have y0 plus h by 2 f of x0 y0 plus f of x1 y1 as our first Euler modified formula, okay? So I'm going to replace as our first iteration x1 as x0 plus h and y1 as y0 plus y0 plus h f of x0 y0 everywhere in this equation, okay? Yes. So let me replace the values. So here are the value I'm going to replace y1 y1 as it is here, y0 as it is here, h by 2 here, f of x0 y0 as it is here, plus, okay. Now this is the time to replace x1 and y1 here in our f of x1 y1, okay. Yes, so replace the value f of x1 y1, okay. F of x1 is x0 plus h, okay. F of x1 is x0 plus h, okay. y1 we have y0 plus h f of x0 y0, okay. y0 plus h f of x0 comma y0, okay. What I have done, guys, only I just replace the value for x1 y1 instead of this function f of x1 y1 over here, okay. This is just the only the replacement of the values, okay. So now we are going to solve it into the some simplified form. Yes, we have little bigger result over here, like x0 y0 f of x0 y0 x0 plus h. This look little bigger over here, okay. So we are going to reduce this value with some another constants, okay. Some another constant I'm going to introduce over here, okay. So wherever you get the f of x0 y0, I found here as well, replace by some another value, okay. So f of x0 y0, okay. I'm just consider here f of x0 y0 as a f0, okay. This one is a short value, and now see that it looks little bigger now. That's why I'm trying to reduce it into the one place, okay, and with some shorter values. Yes, so f of x0 y0 I'm going to replace as a f0 over here, okay. So let's replace the value. We'll see what we get. Y1 which is equal to y0 plus, okay, h by 2. F of x0 y0 I consider as the f0 plus, okay. After that we have f of x0 plus h, okay. After that f of x0 plus h comma y0 plus h f of x0 y0. So then replace the value, okay. This is f0 plus f of under bracket, okay, x0 plus h keep as it is, okay. F x0 plus h keep as it is, comma y0 plus as also keep as it is, plus h as it is here. F of x0 y0 I consider f0, okay, and bracket complete. So see that how I have written this one, okay. So h by 2 f0 plus f of x0 plus h comma y0 plus h into f0, okay. Yes, so I replace f0 as a x0 y0, okay. Yes, so wherever you get the h f0 another more values, okay, try to reduce it into the again another variables. So for this value I consider here h f0, this h f0 as a k1, some another constant. I'm taking some another constant here, okay. H f0 as a k1 and k2 as h f of x0 plus h y0 plus k1, okay. Now see that h take it inside here, h f0 we can write k1, okay. Again h inside here, h f of x0 plus h y0 plus h of f0 as a k1, okay. That means we consider it is the entire as a k2, okay. Let me write with some separate step, okay, that it will be the clear for you all, okay. Y1 which is equal to y0 plus 1/2 keep is it outside, okay, h f0 inside plus f of x0 plus h, okay, comma y0 plus h f0 I consider as the k1, okay. Put it here and bracket complete, okay. So now see that h f0 is a k1 and k2 is a again h it is here, okay. That h we are taking inside here, that it comes here also, okay. That is also coming here, okay. That means k2 we write h f of x0 plus h y0 plus k1, okay. So put these values here, okay. So we write y1 which is equal to y0 plus 1/2 under bracket h f0 as a k1, okay, plus h f of x0 plus h y0 plus k1 we consider it as the k2, okay. this one is the first iteration or first formula for our Runge second order method. Okay, so I hope you all have understood, guys. It's not the difficult, you just need to replace the initial iteration into the our Euler's modified method. Just solve these values, and whenever we get the some bigger values, take it into some short format. Okay, so that it will be easier for us to calculate. Okay, yes, after that replacement, go for the replacing k1 k2 over here. So you will get the first value for y1. Okay, y1 in our Runge method for our second order, y1 is equal to y0 plus 1 half k1 plus k2. Okay, I hope you all have understood. It is one of the easier, guys. Okay, not the difficult. Let me proceed with the some another value. So if you want, you can reduce it into the more shorter values. Okay, so just what you can do, 1 half k1 plus k2, consider it is some another variable. Okay, yes, so let me consider 1 half k1 plus k2 as a k. Okay, let 1 half k1 plus k2, okay, 1 half k1 plus k2, consider it as the k. Okay, so consider this one as entirely k. So we write y1 which is equal to y0 plus k, y1 which is equal to y0 plus this entire value as a k. Okay, so I hope you all have understood how I have written. Just I consider this entire value as a k only. Okay, y1 is equal to y0 plus k. Okay, so here k is 1 of k1 plus k2. Okay, and we know that we consider k1 as hf0. Okay, so what we have considered k1 as here, so see that k1 as a hf0 we consider. Okay, k1 as a h into f0. Remember these values, we need it for our calculation. Okay, k1 we consider hf0, k consider 1 of k1 plus k2. So if you are going to replace this value into our given y1, so you will get the y1 which is equal to y0 plus 1 of k1 plus k2 as a k, y0 plus k. Okay, yes, so we have k1 is a f0. Okay, so what we have k1 is a h into f0. Okay, and this is for our initial iteration. Okay, so what about for k2? So how you are going to write k2? Okay, so for k2 we keep h as it is. Okay, just we extend the value for f0 only. Okay, yes, so for k2 we write f of x0 plus h, y0 plus k1. Okay, we write f of x0 plus h and y0 plus k1. Okay, this is the value for k. Okay, so this h as it is. f0 I extended. When we have k1 we take f0, and when we have k2 we take f of x0 plus h, y0 plus k1. So y0 plus k1 it is coming from here. Okay, y0 plus k. Okay, and if we replace the value from k1 we get the y0 plus k1 from here. Okay, yes, so this is the value for k. Okay, actually this one is generally known as this second order Runge method. Okay, second order Runge method. So see that, guys, I hope you all have understood. It's not that difficult. Okay, we go for some of the example. It will be the easier for you all to understand. Okay, so once we solve some of the example, concept will be the crystal clear. So for our today's lecture, guys, I want you to note it down all these points for our Runge method. Okay, so I applied here Euler's modified formula, and initial iteration I consider x1 y1, and that replaced here into the Euler modified method. As our Euler modified method gives us a little bigger values, so I consider here into the some smaller some another variables. Okay, f0, k1, k2, I replace all these value. I got the y1, then I got the k1, y1, again k1 and k2. Okay, so note it down all these points. I hope you all have understood here in my today's lecture, guys. Even after if you found anything difficult, okay, if you feel that concepts are quite confusing to understand, let me know in my comment section, guys. Your suggestions are always welcome. Okay, so I will upload as per your requirement. So I hope you all have understood here my today's lecture. So we go for one of the example in our next lecture. Okay, so that's it here for my today's lecture. So thank you everyone. Thank you for my today's lecture.